Greetings from Brooklyn, New York, and Terraform One, where we spent a lot of time thinking about the environmental future of cities. This is the cover of our forthcoming book, Design with Life, Biotech Architecture in Resilient Cities. Look for it in the beginning of next year. It's going to be published by Actar. So I'm going to talk about biotech architecture today, and it started with this idea when my co-founder, Mitch Joachim, and I were still graduate students with the idea, can we grow a house out of living trees? So we're not talking about the passive house or the zero house. This house makes a positive contribution to the environment. We're using a very old gardening technology called pleaching, trees together. Our contribution is using computational design to create the scaffolding and to control the growth of the trees. And here we're proposing to grow a whole village out of living trees. And at night, it may look like that, using fireflies to illuminate the house. So it's a slow process. In a New York climate, it's going to take about 15 years to grow a house. So not a lot of people want to wait that long. But we experimented. We started, these are cuttings from willow trees, and these grew up on a rooftop in Brooklyn, New York in 3 months. So you can use certain species to grow houses. And for the purposes of this talk today, I want to define biodesign as the field of design that incorporates living organisms as an essential component, enhancing the function of the finished work. So this is not biomimicry, this is not following nature, this is using nature to grow materials and to grow buildings. So today, I believe design is not simply a creative process, but it's also a focused scientific endeavor. And at Terraform One, we attempt to establish new forms of knowledge of the confluence of design and science activities. So nobody wanted to wait 15 years to grow a factory hub, so we decided to go IKEA style. So we can make you a kit today to grow a kind of a small bungalow, or that can be on the ground or attached to a tree. Here is the scaffolding. It's cut out only of 3 sheets of marine plywood. It's assembled, it comes flat pack, and you can assemble it. It's very easy. There are only 2 distinct components. You make these stars, and then you make the scaffolding, and you can use pre-grown trees and vines to create your factory hub. We've adapted this structure for interior use. We were working with Shanghai Tech to create this structure that now can purify the indoor air. Here we are using, these are wetland grasses that have the ability to, via bioremediation, to purify the indoor air. And they're supported, there is a cistern in the bottom of the sphere, and it's pumping water and nutrition to all the grasses. So this is the structure that was developed for Shanghai. We also adapted the same structure to grow spirulina as a source of food, using Arduino and sensors to control the growth. Just to clarify, spirulina is cyanobacterium that can be consumed both by humans and animals, and it's packed with nutrients. It's currently used as a food supplement, but it's really tasty when it's fresh. And this is, again, the same system that we're using to support the grass. Now we're using it to support spirulina. This is how ripe spirulina looks. And you can measure the ripeness by the dark green color. We created an interface where we, using sensors, you can measure the RGB and know where your spirulina bottles are ripe, and you can harvest them. And of course, there is an app as well. So you can get a text message from your home farm saying, okay, I'm hungry, I'm thirsty, or I'm ready to be harvested. And from spirulina, I'm moving to mycelium. which is the root structure of mushrooms, and it's being now used as a building material. This is the structure of Mycelium. It grows only in 7 days, and it has some really good properties. And here is the propagation. We're using a substrate that is cellulose-based. It's an agricultural byproduct. In this case, we're using corn husk, so inoculated with the spores, and in 7 to 8 days, you have this dense biomaterial that can be applied to many different functions. In this case, we decided to combine it with another biomaterial, which is Acetobacter, which is found in a health drink kombucha, but you can grow it in vats and create an analogous leather material. So what we were designing here was a baby seed, combining these two materials, so Mycelium and Acetobacter as an analogous leather. And here is this baby seed, or here, this is my partner's daughter, Mia, when she was 2 years old. She's modeling for us. So at the end of its life cycle, this seed, it's not going to go into the garbage or into landfill like an IKEA baby seed, but you can crumble it and put it back into your garden, and it's going to feed other microorganisms. We've also developed this chaise longue for adults. This is cut from bamboo plywoods, and it creates a shelf where it can grow the surface out of mycelium again in 7 days. And I have a funny story. I just got a text message from my niece, who is 19 years old. She's a sophomore at a joint program by Risdi and Brown University, where she's studying biodesign, and she's doing an internship at NASA this summer in Northern California. So the text message went, "Aunt Maria, can I talk to you about building on Mars? We want to use mycelium." So it's they are actually researching that this summer there. So. And from mycelium, I'll take you to what will be the smart food for smart cities. This is not a cockroach. It's a picture of a cricket. And there was a report by the United Nations in 2013 that in order to feed the growing population and the need for protein, we'll have to eat insects. Why crickets? Because they use 2,000 times less water to grow a gram of cricket protein versus a gram of beef protein, 100 times less the greenhouse gas. And we set to create the most efficient and hygienic cricket farm. We're adopting water jugs to grow crickets and then combine them into creating a shelter. This was part of a commission that we had by Artworks for Change and the Warhol Foundation. It was a project called Survival Architecture. And we were asked to think about distress situations such as refugee camps. So we wanted our shelter to be also a farm that you can grow food and to teach people how to take care of themselves in that situation. So we can have a whole village of cricket shelters. And here is the full-scale prototype that we assembled at the Brooklyn Navy Yard. So another view. So here are the individual, they're modular farms. We just let them out for the photo op, otherwise they're inside. But here is the design that we are now patenting. So you have the ability to let the crickets go from module to module. When they're big enough to be harvested, they basically get stuck and you pull the sac out. And these are the sex pods that you see. So we are able to introduce a new population all the time, and again control the growth and also control the taste of the crickets. So if you feed them, let's say, apples or limes, that changes the taste. And what started as survival architecture, now we are working with gourmet chefs in New York who are interested of cooking with crickets. The good news is that you don't have to eat the whole insect. You grind it into a flour and you can make pasta and bagels, and it's actually delicious. And it's now offered in restaurants throughout the city. And from crickets, we're going to bioluminescence, there is this protein in a lot of creatures that, when reacts with oxygen, emits light. We're used to looking at this picture of the world, but this is what the ocean looks like, we are using the protein in jellyfish, cross-linking it with E. coli to emit light, and this is a study for the population growth. This is a project for the Venice Biennale in 2014. Here we are using a computational map using the Buckminster-Fuller Dymaxion projection of the world. We combined all the available data to look what the population will be 100 years from now, and we identified this hotspot. This is India. You can see there are these hotspots of mega cities that will occur there. So one side of the map, using this number, we extruded this population growth to look at this one gigantic city of 11 billion people 100 years from now. And this is what it's going to look like. But the really interesting part is the other side of the map, where we are using these genetically modified bacteria to study the population growth of these 25 hotspots that we identified. And it expresses luminescence under long wave UV. Again, these are the 25 hotspots. So E. coli has been used before to study population growth. What we did for the first time to do it is to do it spatially. Here we have both the existing population and the prediction in two different colors. So this is the map of Istanbul. The Bosphorus is in the middle, and here is kind of the projections of what the population growth is going to look of Istanbul 100 years from now. And I just want to end with our latest project. It's not finished yet. Oops. So we are working with a developer in Soho in New York, and we're developing this building that is going to have a Monarch Sanctuary in a double skin facade. So monarch butterflies are going extinct. They're very sensitive to both the air quality but also to chemicals in plants. So what we are creating here, it's a vertical meadow that we are measuring what are the optimum conditions to grow monarch butterflies. And the idea is that we'll take them through a whole life cycle and then release them in the end. But also, this double glazed facade communicates and it becomes part of the building system. And we are want to introduce this healthy microbiome. If we have these optimum conditions for butterflies, that's also really good for humans. And recent study shows that by using the mechanical HVAC systems, we are sterilizing the air in the indoor air, and that's not healthy for humans. And a lot of what we call first world diseases, such as allergies and asthma and even autism, are being now contributed to this sterilized environment that we live in. So we are trying to create this new positive microbiome by introducing the healthy bacteria back into the air, and having a building system that incorporates living system that is both good for humans, for plants, and for butterflies. And in the very end, we are also working on creating a robotic butterfly. So it's like a shepherd for the monarch butterflies, but it's also an air sensors, and it has the ability to collect samples and map the microbiome. And you imagine if you are in some place like Shanghai today, you can send your robot butterfly outside and determine if the air quality in the nearby park is safe for your children to play. So again, look for Design with Life next year. And I want to leave you with one question, again, channeling Buckminster Fuller. Can we make the world work for 11 billion people in 100 years from now? Thank you.